Welcome to video 11.8, writing equations with vertical and horizontal shifts. So in exercise 1, we're going to determine the key point and describe the translation that is applied to this parent function to make w of x equals the square root of x plus 4 minus 2. Well, the first question is, it talks about a parent function. What does a parent function mean? Well, that means that it's the most basic form. So what is the parent function of this if we're looking at the square root of x plus 4, then minus 2? That means the parent function is just plain old square root of x. So the question is, what's the key point here? Well, what happened to the key point? It was at 0, 0. Now it's going to be plus 4, but that we would think would mean positive, but it's the opposite of what we think. So it actually means left 4, which means that it's going to move from 0, 0 back 4 spaces to negative 4. And then we see this minus 2 here. That means that it's moving down 2. So it's the opposite of the inside number, or the one with, under the square root in this case, it could be in parentheses with the x, and then we move up or down. So what translation was that? It was translated left 4 units and down 2 units. What happened to the x value in the equation to make the key point? Well, we already talked about this makes the opposite or inverse of the number that's under the square root with the x. So remember, it's always the opposite for the x. And then what happened to the y value in the equation to make the key point? Well, if we look, we can see that it's the same value, and we have already talked about this a little bit. So this is the same value as the number outside of the square root. So opposite for the x, same for the y. So horizontal and vertical shifts written symbolically using function notation. When we have a horizontal shift, or the x part, the k number inside the parentheses, so we have like an x plus k. It's happening with the x. A vertical shift, or the y part, the k number is outside of the parentheses, so it'd be like the function plus k. Okay, in exercise 1, given the function f of x equals absolute value of 3x. If g of x equals f of x minus 2, how is the graph of f of x translated to form the graph of g of x? Well, if we look at this, what's it going to do? Well, in place of the f of x, we're going to put what f of x equals. So it's still a lot of this substitution idea. So I'm going to replace f of x with this absolute value of 3x. So what it would look like is g of x equals the absolute value of 3x and then minus 2. So what happened to this? We look, it's an outside number that's changing, so it's translated down 2. So that's what that tells us, because that minus 2 was an outside number here. Okay, so now if we look at the part B here, if h of x equals f of, now we have x minus 4. So x minus 4, that means that it's replacing with the x value. So if I write this, I'm going to replace the x minus 4 in place of where I used to have an x value to make this h of x function. So if I look here, now we've got something happening with the x. So that means that it's going to be a horizontal movement, and it's the opposite of what we think. So when I see negative 4, I think, okay, well, negatives on the graph go left, but it's the opposite of what we think. So this is actually translated right 4 units. So again, that's just the opposite of what we think. Okay, let's look at exercise 2. The parabola represented by f of x equals x squared minus 4x plus 3 has a vertex. Now this is a little bit different. They're telling us what the vertex is. And we want to find the vertex of a parabola that's defined by this new function. And then we have to explain how we arrived at our answer. Well, if I look, it's starting off at 2, negative 1. So I can sketch that as over 2 and down 1, just so I kind of get a visual of what that looks like. And this is telling me I want to move, we would think left 2, but it's the opposite of what we think, so right 2. So if you can picture it on the graph over here, if I take my point from where it is now and then move it right 2, my new point would be 4, negative 1, the equivalent of adding 2 to my x. And I explained by saying I found my answer by identifying the transformation as translating right 2 units and sketched a graph finding that it would add 2 to the x value. Okay, exercise 3. Write an equation d of x for the image of the graph f of x equals the square root of x if f of x is shifted 3 units left and 4 units up. So the two important pieces are 3 units left and 4 units up. So how do we write this whole shifting 3 units left? Well, since it's talking about a left or right, that's an x movement. So for that, we need to think the opposite of what it is. So what I would think, shift 3 units to the left on the graph, I would think, okay, well, if we have my axes and we're going to the left, that would be going towards the negatives. But it's the opposite of what we think. So in pink, I just wrote that. The whole think it's negative, but it's the opposite of what we think. So when I write the function, and remember that we need to write an equation d of x, so I'm going to start by writing d of x because it's a different function. I can't rewrite it as f of x. I already have an f of x function. So d of x equals, it used to be the square root of x. Now it's going to be the square root of x, and from my information I put over here, it's going to be plus 3. Okay, so that takes care of the first part. Now the second part is this whole moving 4 units up. So now outside of that, I'm going to put the plus 4 because it's a vertical movement, which is the same as what is written here. So now that's my answer. D of x equals the square root of x plus 3 and then a plus 4 outside of that. Now remember, you can always put these in your calculator. So you can put the equations in y equals and check the graph and or table to make sure that it did what the instruction said. So if I put in the square root of x in y1, and then I put the square root of x plus 3 out of the square root plus 4, and I check my graph, I should see that it translated left 3 units and 4 units up. Okay, exercise 4 says we need to write an equation, k of x, for the image of the graph, w of x equals x squared. If w of x is translated 2 units right and 7 units down. Okay, so when we say that it's translated 2 units right, we would think that right would be going to the positives on the graph or going right to plus 2, but it's the opposite of what we think. So instead of plus 2, it's going to be x minus 2. So that's my kind of note off to the side. We need to make sure that we remember that. So the new function, well, I highlighted it in the word problem. It said to call it k of x. So I wrote the k of x, and now instead of being x in parentheses, I'm putting the x minus the 2, like I wrote off to the side. It's still being squared like the original function because it's a parabola. It can't all of a sudden no longer be a parabola. It's just being moved. It's still a parabola. And then the second part is that it's moving down 7. So that's on the outside since it's a vertical movement, and that's where I put the minus 7 since it's the same as what we think. Now, you can check this in your calculator, but this is my equation. So the question is, how do we check it? Well, we would put the w of x function, x squared, in y1, and then we would put our new function, x minus 2, in parentheses, squared, minus 7, in y2. Then take a look at the graph and see, did the key point go what we wanted it to go, which was right 2 units and down 7 units. Make sure that that is what happened. That's a good way to always make sure that you remembered to use the opposite for the inside and the same for the outside. Okay, exercise 5 says that we need to use the function m of x equals the absolute value of x minus 5. So given that function. So now I brought up a picture of the calculator, so I'm just showing you the buttons that you need to press, but unfortunately the screen won't change. To put in the absolute value, so first let's start with m of x equals, which is a fancy way of saying y equals, so press the y equals button right here. So y equals, and then we're going to put absolute value. So to do that, you need to hit the math button, and then that'll bring you up to a new screen on your calculator. And if you press the over button, the tab at the top of the screen up here, the second one here will say NUN, and then choice number 1 says absolute value. So you can either hit the number 1 or hit enter so that it selects the number 1 since your cursor is already on 1. So that's math, over to the num tab, and then enter. That'll give you absolute value bars if you have the newer calculator, or the older calculator will just tell you ABS, standing for absolute value, with a parenthesis opened up. Then you're going to put the X into the parentheses in the older calculator, or absolute value bars in the newer calculator, and get out of there if you have the newer calculator, or close your parenthesis if you have the older calculator. Then you'll put the minus 5. You have to make sure that the minus 5 is outside of the square root because this is saying it's a vertical movement down 5 units. But if it were inside with the x, that would have been a horizontal movement, saying that it was moving the opposite of what we think. We would think left 5, but it's actually moving right 5. So all of that to get that into y equals. So hopefully your graph will show the absolute value of x and then the minus 5. If you've done that correctly, then your turning point or vertex should be at 0, -5. And we can see that in the calculator by looking at the graph or the table. You can also take it from this function. Since nothing happened to the x value, it'd still be at 0, and this would mean down 5, which is why the y value becomes -5. The next question says, what is the parent function for m of x? And name it p of x. Remember, we're using p of x because we have to call it something different. It's a new function. So in this case, it's the original function. The parent function, remember, is the most basic form. So nothing has happened to it. So the most basic for an absolute value is just plain old absolute value of x. No inside or outside numbers because nothing has happened to change my function. The next one says, describe the translation that maps p of x to m of x. So in other words, how did I get from the original, the p of x parent function, to m of x, my new function, the absolute value of x minus 5? We already talked about this. I told you since there's no change inside with the absolute value bars, the x did not change. So the minus 5 on the outside shows us that it goes down 5. You can also do this by looking in your calculator and saying, okay, let's put p of x equals the absolute value of x in either y1 or y2, and then put the absolute value of x with the minus 5 outside of the absolute value bars in y2, and check the graph, and you'll see that it did move down 5 units. The next one says, write an equation for m of x that applies the translation rule to p of x. So, in other words, we want to make m of x equal to this function and then what happened to it. So applying that translation rule. So using my function, all I did was take the parent function and subtract 5 or move down 5 units. Exercise 6 says consider the function h of x equals, and then we have the x plus 7 in parentheses being squared minus 15. The function w is defined by the formula, and then we have a new formula, w of x equals h of x minus 6 plus 9. What is the new equation for w of x? Okay, so to find this, we need to figure out what is this information telling us. So that's the first part. I need to look at the x minus 6. What does x minus 6 say happened? Well, we would think, since it's a negative, that it moves left 6, but since it's the opposite of what we think, it didn't move left 6, it moved right 6. And then the plus 9 tells me that it moved up 9. Now we need to find out what the new equation for w of x is. So in order to write that, I'm going to start by saying, okay, the turning point for this is -7, -15. There's two ways to find that. You can say, okay, I know that it's the opposite of the inside, the same for the outside, or if you can't remember that rule, go to y equals, put this into your calculator, and then look at the graph or the table to find the turning point. So this is my turning point. If it's moving right 6, then that means that I need to add 6 to this x value. When I add the 6, that gives me my new x value of -1. You could also look at this on the graphs. If you've already put this in y1, look at the graph and you'll see it over at -7, -15. And you can just take that point when you see it on your graph and move it with your finger or visualize it moving. So when it's over here at -7, then you would move it right 6. But it's harder to do because this x and y value are bigger than what we did in the previous example. So that's why in this case I wrote the +6 instead of trying to sketch out a graph and showing -7 and then down 15. It would have been a lot of marks to try to draw that. You can though if that's easier for you. And then when I say it was at -15, it's moving up 9. Well, -15 and then add the 9. And then that'll give me my new y value, which you can just put in your calculator, -15 plus the 9, and you'll get -6 for my new y value. So my new turning point is -1, -6. Now that I know where the turning point is, I can write the w of x function. So I'm going to start with the x in parentheses like it was in the h of x, but instead of being the plus 7, we know the turning point is at -1, so that means it's the opposite of what we think, so it would be a plus 1, and that's being squared. And then outside of the parentheses, the vertical movement, then down 6, so -6. So that's my new function. Now, I did sketch it off to the side. Again, I think that this was harder for me, but for some, the visual might really help. So I did sketch off the original. So we had the h of x equals the x plus 7 squared minus 15, which we can either get by looking at the table or using the opposite and same side rule. So I knew that it was at -7, -15. And then I just said, okay, if it moves right 6, so right 1, 2, 3, 4, 5, 6, and then up 9, and then it went to this new point, which is -1, -6, so that's where this would have came from. And you would see that if you put this in y2. So it's a really tricky concept. Hopefully one method works for you to identify the change and write the new equation. Okay, exercise 7 says that we have the vertex of a quadratic function f of x is -5, 6. Find the coordinates of the vertex of the parabola defined by w of x equals f of x minus 3 plus 2. So again, those two options that we have, we know the vertex, it's -5, 6. So I wrote that down. Now this says f of x minus 3. So what are we doing with the x value? Well, we would think left 3, but it's the opposite of what we think. So this means that it's moving right 3 and then outside up 2. So I'm going to add 3 to my x value. So when I add the 3, that gives me -2 is my new x value. And then up 2, so that means to the y, I'm going to add 2. So 6 plus 2 gives me my new y value, which is 8. So my new turning point is -2, 8. That's the new vertex. That's my answer. Okay, so off to the side, I also sketched the graph. So if you like to use that method, so the original vertex or turning point here is -5 up 6. And then it said that we're moving right 3 and up 2. So you can just plot your point and move it right 3 and up 2. And then that'll show you your new point, which matches what I have, the -2 up to 8. So either method works, but I think it just gets harder when you have bigger numbers, so it's helpful to know what we're doing to the turning point. Okay, exercise 8, write a possible equation for each function graph below. Use the location of the key point and the translation it took to get there. So in all of these, we're talking about the parent function and then how it changed. So when we think of the parent function, for this one, it would just be the square root here. And that's, you have to recognize that this is the square root graph. So the square root of just plain old x would have been over here. So what happened to that turning point, which would be at 0, 0? It moved left 3 and down 1. So I just wrote that off to the side, left 3 and down 1. So what would my new function be? And in none of these, they didn't put any labels on them, so you can use whatever you want to use. I'm just going to use f of x for the function. So like I said, in this one, you just had to know that it was the square root, but it's no longer the square root of just x because it moved left 3. So opposite of what we think, so it's the square root of x plus 3. And then since it also moved down 1, we're going to put the -1 outside. So that's my new function. Okay, so the next one, again thinking the parent function. The parent function is actually just x squared, so that would mean it's a smiley face parabola going through 0, 0. So what happened? Okay, well, it moved. First, it left 2, and then we actually reflect over the x-axis to make it a frowny face. And then it moves up 5. So I just typed that up above so you can see left 2, reflect over the x-axis, and up 5. So then we need to write our new function. So I just showed here, I put the negative because if we were looking, okay, left 2, that means inside, it's the opposite of what we think, so below plus 2 in the parentheses with the squared, but then the reflect goes out front, so that's why I have the negative here. And then we have the up 5 plus 5 at the end, and that's the equation of that function. The next one we know is the absolute value, and what's happening to the key point? Well, it was over here, so it moved right 2, down 1. And then I'm just going to use the same f of x function. You could use different letters if you wanted, but I just used f of x each time. So we have absolute value. Since this is an absolute value graph, it's x, but so since it moved right 2, we're actually going to put the -2 since it's the opposite of what we think. And then close the absolute value, and then the same for the outside. So down 1, we put a -1. And that's the function there. So hopefully this video helps. Have a good night.